Eclipse, we're going to create a project for today. And let's say, in my case, gotta change that. Okay, so today will be week 11. So let's say new Java projects, CSE114, Spring 16, week 11, lab, let's say 1. Okay, that's what we have today. And we're gonna have two versions of the the two kinds of students to show you one without any inheritance, the other one with inheritance. So now we can use a package in Java. Okay, so if you do package is like a folders in your computer, just to have a way to organize different files into different folders. So now you can say new, right click on your projects and say new package. Let's make it more explicit. Let's say with inheritance, like that, with inheritance. Okay, and let's create another package without inheritance. And the convention in Java is all the names in the package will be all lower cases. That's a convention, and separated by underscore. Kind of weird convention, but just the convention without inheritance. Okay, so now if you right click on the package without inheritance, so that's the first version we're going to try. Right click and then say new and then class. Okay, so remember we got two kinds of students. We got let's create a course first. We need a course. So let's say course. Over here, you can see here on the first line, Eclipse puts for you, it's under the package without inheritance. So later on, we're going to have exactly the same classes with the same name, but in a different package. So that's easier for you to distinguish. So now for the course, we have a very similar, very simple attributes. Let's say just title and the fee. So string title, and also let's say we have a double type fee. Let me just open the door. It's a bit warm. Okay, so now we also have a double attribute here. Let's say fee. Okay, let's say for the constructor for the course, we are simply going to initialize the title and the fee. String title and double fee. So you can say this dot title is assigned to title, and this dot fee is assigned to fee. You can see how useful this keyword is. You don't need to think about different names for the parameters. Very convenient. Okay, that's about the course. So now let me just close other tabs. Okay, let me go back to the without inheritance package here. Can we just create another class? Let's say resident students. Resident students. Okay, you can see now we are still under the without inheritance package, and now we have a class called resident students. And if you refer to your handouts from today, so for resident students, we have name and courses, a number of courses. So we have string name of the students, and also we have integer, the courses. So we have a course array. So register courses. Okay, we can just call it courses. It's up to you. And also for the array, we need a counter to manage that. So integer, the number of courses. Okay, 3 attributes so far, and also for the resident students, we have the premium rates. Okay, which can be any double number. Okay, so we have the so these are the 4 attributes. So one thing to note, only specific to resident students. Actually, let me just make the comment a little bit better for you. So only this attribute premium rates is specific to resident students. On the other hand, we have repetition here. You can say these attributes are common to resident and non-resident students. Yeah, maybe just separate it into 2 lines. That's easier. Okay, just comment for you. But once we use inheritance, we can actually factor out these common attributes into a separate class called parent class. That's what we will do. So my point is the 3 attribute name, register courses, and number of courses. These are common, so they can be factored out later. But for line number 12, that's the attribute that must exist in resident student class only, but not both. Let's see how we do the constructor for resident students. So now we can say resident students. Let's say we simply take the name of the students. Name here. So there are several things we can, 2 things we do. First of all, you can say this the name is assigned to name. Okay. And also we're going to initialize the array. So register courses is assigned to new course array. Let's say 30. Let's just follow what was said in the slides. Just 30. Of course, what you could have done is to say final integer, let's say maximum number of courses is assigned to 30. Okay? And then you can reuse this constant over here. Slightly better. Okay, that's the constructor. And then let's see how we implement the register course. So you can say register a course for the students. So it's going to be a mutator, returning void. Okay, so now let's just call that register course. And then it's going to take a course object, C. Okay, and the way you do that is very standard. So you can say, why don't I give you 30 seconds to complete that? Right? How would you complete that? Okay. So we should assign C into the right relevant spot, the right spot in the courses array. Register courses at position the number of courses is assigned to C, and then increment the counter by 1. Okay, that should be very easy. Okay, another method here. Based on the current register courses, we would like to calculate the tuition for the students. And we first of all have to calculate the base amounts for all the courses, accumulate them together, and then apply the premium rates of these resident students. Okay, so it's going to be, let's say, calculate the tuition of resident students. How do we do that? So since we're going to do some calculation and return the results, so this is going to be, rather than a mutator method, it's going to be an accessor method. So it's going to return the double, and then you can say get tuition. And so now you can see that the method here does not take any parameter. So how would you justify that? You say I don't need any parameter, any input. Return? No, actually I'm asking. So here, let me just phrase my question better. I'm asking why did I leave this part here just empty? So why do I not take any extra inputs in this case? Why would it be sufficient for me to actually calculate the tuition without taking any extra parameter?
Because you just need the students, so the student dot
No.
There's 2 cases. At this point, we only calculate the premium rate, but then the ones who are not, you have to also account for discounts. But if you're just getting the tuition, then you might have to do both. In that case,
That's actually another point, but that's not about justifying why we have empty parameter here. Okay, let me just put my question more carefully. In the comments, I don't answer that. Okay, but it's good that you guys are thinking. So, question: why get tuition method takes no input parameters. Okay, you can see here, you can see it's simply just empty, no parameter. Okay, the answer is it is sufficient to use the register courses attributes to accumulate the fees of courses. That's sufficient. Okay, so the idea is you will only need parameter for your methods if the current attribute values are not enough for you to do the computation. Okay? If they are enough, you don't need any parameters. If they are not, you need parameter. There's some design issue here. Okay, so now let's see how we can do that. So now let's declare a local variable here, just double tuition, initially just 0. TUI tuition, and eventually we are going to return tuition. Okay, so let's say this tuition here, first of all, we have to accumulate the fee of each course into the tuition. So the way we're going to do that is by using a for loop. So integer I is assigned to 0, I less than the number of courses. I also try to explain why in the class you have to use number of courses rather than register courses.length. Again, question here, why number of courses rather than register courses.length. Okay, that's also another important question for you to answer by yourself. Okay, and then here with I plus plus. Okay, so now we would say accumulated tuition plus equal, and then help me out here. What should I write? What should I write here? You have your code here, so what expression should I put? So in each iteration, I'm going to increment the tuition by certain amounts. But what should that amount be?
Register courses IFT.
Aha, very good. Very good. I hope that's what you guys meant to say, right? Register courses at position I dot fee, exactly. Okay, so that's a very important documentation to use. Something that you will be expected to write in the picture. Okay, that's how we accumulate the tuition. So after the for loop, the tuition would be the base amount. So after the for loop, tuition has the let's say as the base amount. Okay, so now we just have to apply that base amount to some premium rates. So now you can say you can either say tuition is assigned to tuition multiplied by the premium rates. That's one possibility. Or you can simply return tuition multiply premium rates. It's up to you. Okay, so I'm just giving you a slightly different version from the slides, but both should work. Any question up to now? No? Very good. So as we agree in the lecture, if we want to define the other class called non-resident students, things will be very, very similar, right? There will only be just one or two minor differences. So I would suggest the following to save our time. First of all, let's create a class. New, and then class non-resident students. Okay, and then let's go to resident student here. I'm going to copy everything until the end of the class over here. So leave out the last curly brackets here. Okay, leave out. Okay, so basically from line number 1 of the class up to the last line of the class, except for the curly brackets here. Copy. Okay, you can say edit and copy. So now go to my resident students where the body is simply empty. So paste that. You can say edit and paste. Okay. So far so good. Okay. There are only a few things we will have to change. Okay. First of all, rather than having premium rates, we should rename that. Okay, let's do some renaming in Eclipse. So you can right click on that and then go to refactor and then rename. Okay, let me do it again. So right click on the attributes and say refactor and then rename. Okay, so now rather than premium rates, we're going to say discount rate and enter. And just say continue. So now it has been renamed systematically. Okay, that's what you should really aim at doing rather than renaming manually. Okay, so now tell me something. Why line number 14 wouldn't compile? Why is that? Not compiling. Line number 14. Yes, exactly. Very good. So because now, if you only have the method without any return type, Java compiler will assume it's the constructor of the class. And the name of the constructor must be the same as the class name. So it has to be non-resident students rather than resident students. Very good. Okay, non-resident students here. Everything else is the same. We got registered course, and now you can see everything else. Yeah, after we rename systematically, we don't have to come here again. And that's it. That's non-resident students. Oh, sure. Let me change it back. For example, if I want to rename this discount rate here, so right-click on the attributes, and then go to refactor, and then rename. Okay. So now, once you get it, you can just rename to whatever name you like, and then enter. Okay, so that's about this. So can we just do some tester quickly? Okay. So now right-click on the package there. We say new class. Let's say student tester. Okay, so now we're still within the package without inheritance. Let's see, for the tester, let's do something simple here. Let's say we create two courses. Let's say course, let's say CSE114. New course, let's say CSE114, computer science 1, that's a title, and also the fee. Let's say it's $500, for example. Okay, let's have another course CSE214. New course, computer science 2, also $500. Okay, two courses. Let's say we have two students. So let's say resident students. Let's say Jim. It's assigned to new resident students and just the name. Let's say Jim Davis. Okay, let's have another one. Let's say non-resident students, a different kind. Non-resident students, Jeremy. New non-resident students, and now I can say, let's say Jeremy Gibbons. Okay, just two different students here. So now let's try to add courses to the students. You can say Jim.add our register course. Jim. Why do I not have that? Let's see. Resident. You're absolutely right. Yes. Wow. Good. You're definitely ready for the midterm. That's good. Okay. Main method. I'm not ready. No, sorry. The main method here. Yeah, absolutely right. Yeah, exactly. So Jim.register course. CSE114. Okay, that's one here. And then let's say Jeremy dot register course CSE214. Okay, so now Jim has one course and Jeremy has one course. They happen to have the same fee, 500 and 500. But because Jim is a resident student, so we have to set the let's say after we created Jim, so we can say, oh, we forgot to define some methods here. So if we can go back to resident student here, okay, let's define a mutated method there for setting up the premium rates. So that's what's missing from the slide. We simply assume it's there, but now in the lab we can do it. So let's say void set premium rate. So let's say double premium rate here. So you can say this dot premium rates is assigned to premium rates. Very easy. Okay, just a standard mutator method. If you go to non-resident students here, we're going to have the similar mutator method for discount rate. So again, mutator here. So set discount rate double discount rate. Say this dot discount rate is assigned to discount rate. Okay. Okay. So let's go back to the tester. So now over here, we can say gym.set premium rates, let's say 1.25. And for Jeremy, because he's a non-resident student, Jeremy.set discount rate, let's say 25% off, for example, like that. Okay. So now we register one course for each student. So now let's print out their tuition that's due. So you can say system.out.print. So here you can say, let me use two print statements for you. So tuition for resident student gym. Okay. And make sure I put a semicolon here. System.out.print line. So now I can say gym.get tuition. Okay. And you'll do the same for Jeremy. So now tuition for non-resident students, Jeremy, that would be jeremy.getTuition. And once we actually have done the inheritance for the second version, we can reuse exactly the same testing. We say that the external behavior of the program does not change. It's only the internal organization of the classes we have changed. Okay, let's try that to make sure we got sensible answers. If you launch the program, you will see that, okay, that makes sense. So Jim, although they got 500 base rates, but for Jim, he's going to get 1.25 premium rates. And for Jeremy, it's the 0.75 discount rate. Okay, any question up to now? No? Yes? No? Are we good? Okay, I'll take silence just in case. And now we have to see, you can see lots of duplication here. So now we would like to use the version with the help of inheritance. This is how we do that. Okay. So now if you go back to be honest, even for the version 1, that can be a very good case study for your midterm. Because for that one, even though we didn't use inheritance, but to see how we actually manage the array and calculate the tuition for the students, that's also valuable sources for studying the midterm, right? It's just the inheritance part that's not covered in the midterm. Okay, let's now, we would like to create a new version with inheritance. Again, let's create a, so now right click on the other package with inheritance. Click on that and say new class. So now we have course here. Okay, course here. And if you can just go to the, okay, let me show you where you should go. If you see the package without inheritance, remember we had a course class over there. Click on that. So just copy the definition there. Okay, it's the same really. Okay, so you can see that's the new version there. Just copy the definition. So the two course classes in the two packages are identical. Okay, after that, we're going to create a new class with inheritance. if we can say new and then class, students. So this student class here will contain all the common parts for the two kinds of students. So this student here will be the parent class later. The parent class or the super class. Okay, let's say create a student class over here. So now how do we define that? Okay, let me just define from scratch. Okay, let's not confuse you. Okay, now for student class, let's see what should be in comments to the students. So again, for each student has, let's make some comment here. This class defines attributes and methods that are common or shared, that are common to or shared by the two kinds of students. Okay, that's the purpose of creating this class. And let's just do it from scratch, so rather than copy and paste. Okay, the common attributes number one. We have string name. Each student has a name, no matter regardless of resident students or non-resident students. Both have a name. And also, we have both students have a course array for register courses. So this part is also shared. And also the counter for managing the array is also shared. Integer, the number of courses. Okay, so these are the three attributes that are shared. You can see that, let me put a comment for you. Premium rates and discount rates are not shared by both kinds of students. Instead, each one of them is specific to only one class, only one kind of students, but not the other. Okay? That's why we don't declare premium rates and discount rate over here. We don't. Okay? So now let's see how we define a constructor, which is pretty much the same as what we did. So you got student here, and then it's going to take a string name. Okay. So now it would say this dot name is assigned to name, and let's also define a constant here. Final integer, maximum number of courses. Okay, let's say it's 30. Okay, so you would say register courses is assigned to new course, and then we can now use the constant. Now to here. Okay. Yeah, so these are the two assignments we need to do for the constructor. Okay, that's a constructor. And then we also know that for the register method, it will be shared completely. So you can say that the register course method will be shared completely. I'll just say completely. Okay, so now when we do register course, we the same as before. Void register course C over here, and then we'd say register courses at the number of courses is assigned to C, and then the counter plus plus, right? So this will be inherited to both classes, as we'll see. And then we can do get tuition. So the get tuition method will also be shared, but each kind of students will also redefine this method. Okay, we'll see how they do in a moment. Okay, somehow they will redefine that by applying different rates, either premium rates or discount rates. So we got an accessor method returning a double, get tuition here. Again, it takes no parameter for the same reason as before, since having the courses array will be sufficient to figure out the tuition. So double here, tuition, let's say initially 0, and eventually we'll return the tuition. Okay, so we're going to run the loop as before. So you say integer I is assigned to 0, I less than number of courses I plus plus. Okay, so you would say tuition plus equal, and as before, you would say register courses at position I dot fee. Okay, that's it. Okay, so somehow this get tuition method will be inherited to resident students and non-resident students. But in each class over there, you have to apply different rates. That's why we call it redefine or override. We'll see that. Let me make some notes over here. Let me put a note here. This version of the method will be redefined or overridden. So it's kind of funny spelling, overridden. O-V-E-R-R-I-D-D-E-N, overridden. Okay. You say to override a method, or you say the method is overridden. Okay. Okay, so it will be redefined overridden in resident students and non-resident students. Okay, so in the resident students, you have to apply the tuition base rate to a premium rates. In a non-resident student class, you're going to apply that to a discount rate. Okay, that's what the redefinition means. Okay, so now let's see how we can do for the 2 student classes. Yeah.
The get tuition is spelled wrong.
Yes, you're right. You're right. Absolutely. Yeah, good. Get. Good. Thank you. So now let's see how we can use inheritance. Okay? So now this is a common parts that's going to be shared by resident students and non-resident students. Let's see how they can share the code. And we're going to show that in the debugger as well, so that'll be even clearer. So can we just go back to your package here with inheritance, and let's create a new class over there. Let's call that resident students. Resident students. So now, one very important thing to note. So here, we're going to say extends students. You have to declare this at the top level. So what does it say? Yeah, don't worry about it. Yeah, so just do this first, and then we'll define the constructor in a moment. So we are saying that the resident students is a child or subclass of the class students. So it is going to inherit all the attributes and methods from the student class. Okay, that's what we declare. So now let's see how we can define the constructor. Okay. Oh, first of all, so let's say this. This class inherits. So if you go back to the student class, you can see the first 4 attributes here. So they are inherited. So there's no need to redeclare them. So let me just put in there. Inherits name. Let's say attributes. The following attributes. So you got name. You got register courses. The number of courses, and also the maximum number of courses. So there is no need to redeclare them in this class. Okay, that's important to note. Okay, I'm just putting a comment here. But now we're gonna have a new attributes for resident students, which is premium rates. Declare a new attribute specific to resident students. So, which is the premium rates. So we would say double premium rates. Okay, so far so good. You can see in this class here, we only declare one attribute, but somehow it's accumulative because in the parent class, we got 4 attributes. And now in this class, we got 1 attribute. But overall, we also got the 5 attributes, just that the 4 that's inherited are implicit. Okay, so now let's see how we define the constructor. So now, resident students, okay, the same name as the class, and then it's going to take string name. Okay. Okay, I think there's typo there. Okay, so now let's see. Okay, so now we have resident student. Let me just make sure I don't make any typo. Okay, we have resident student here. So now the way to call the version of the constructor in the student class, which is here, right? Somehow we want to call this constructor as I illustrated on the board today. So this is how you do it. You say super. Okay, super means go to the constructor in the parent class, which is students, and then invoke that constructor with name. Okay, that's what it means. Remember the very last diagram I drew on the board? I said student here and resident student here. When you call super, it is as if you try to call the student's constructor with name. Okay, let me again make some comment here. This is as if you say students with name. And let's say as if calling the constructor student name. And the student constructor comes from the parent class. Okay, so now, because we know the way we register for the course is pretty much the same. It's exactly the same as the parent class. So there's no need. There is no need to redefine the register course method. No need. Okay, it's just there. Okay, so now I just put a comment there. However, we must redefine or overwrite the get tuition method to account for the premium rates. We can see is that actually we got 2 methods here. One is the register course, which you inherit completely without any redefinition. But the other one, we have to redefine that to account for the extra attributes. So different situation here. Okay, so for now, how do we do that? First of all, we have to redeclare the method. We'd say double, it returns a double. So get tuition here. Okay, so now we want to say somehow double, let's say base tuition is assigned to. So now we want to reuse the fragment of code that is defined in the student class. You can see we want to somehow reuse this fragment of code over here. The way to use that is by, again, using the super keyword dot get tuition. Okay. And then after this, we can say return base multiply premium rates. And that's it. So far so good? Okay. So now you notice a subtle difference here. In line number 13, the way we call the constructor from the superclass is by saying super only without any dot notation. But now in line number 21, if you are trying to call a method from the superclass, you would say super dot rather than this dot. You can think of this and super are like the current class and the parent class, right? Different keywords. Okay. In some ways, super is like this, but you're talking about the super class. rather than the current class. Okay, pretty good. So now let's finish the non-resident students and we'll do some tests. So now we have over here new class. So non-resident students. And now let me show you something here. So rather than manually writing out extends students, you can see there's a superclass over here, right? So you can now browse. And over here, just type students. And you can see, make sure you select the right one with inheritance, right? In this package here. Select that, and then say finish. Should I do it again? Okay, let me do it again, okay? So now once you type the name of the class over here, so now in the superclass, you can see there's a superclass text field over here. You can say browse. Okay, and now you can just type the name. You can see there's a student with inheritance. So this is a package name. That's a package we are currently in. So that's a student class from with inheritance. Okay, so you would say okay here. Okay. What? Sorry. Does it crash? If I say finish, yeah, it's now finished. Okay, good. Okay, that's how you did it. But if you if you didn't follow, you can follow the video again. It's actually quite easy. Or just type it manually. So now for the non-resident students class, we're going to do something very similar. Can we just go to the resident students to save our time? So now for the rest, if you go back to the resident students class, you can basically just copy everything. Okay, starting from line number 4 here, okay, until the second last line, except for the last curly brackets. Go to edit and copy. Okay, and let's go back to the newly created non-resident students class. Put your focus here, and then edit and paste. Okay. Of course, if the indentation is bad, you can select them and then go for source and shift to the left. That's also what you can do. Okay, just only a few things to change. So now, again, the constructor name is wrong. It has to be the same as a class. So you can fix that. Now resident students, and now it compiles. So now we just have to rename the attribute. Rather than premium rates, it has to be discount rate. So now we gotta say refactor and rename. So discount rate. So now one question for you. So we are still missing two methods here. Remember in version 1, without the inheritance, we have set premium rates and set discount rate. We still have these two methods. So should we define these two methods in the student class, or should we do that in the resident student class and the non-resident student class? Where should we do? Where should we define it? That's the question. So you got two options here. Let me make it more explicit. Option number 1. Let's say we have student. Remember, we have student class here, and we have two classes that extends that. So we have, I say, non-resident students and resident students. Okay. Option number 1. We define set premium rates and set discount rate over here. That's option number 1. Option number 2. We define these two methods in separate classes. So option number 2 in blue. So for example, for resident students, we say set premium rates. So here we say set discount rate. Option 1 or option 2? So in option number 1, it seems to be the good thing is if you define the premium rates and discount rates, I mean the mutators here, they will be shared in those two classes, right? On the other hand, if you do that here, you can see the set discount rate is only applicable to non-resident students, and the set premium rates is only usable by resident students. So now, any option, any thought?
Because the set premium rate and discount rate is specific, don't we have to do it in two separate?
That's a very good thinking. Yes, that's what I originally thought. That's good. So now let's say this is option 2, and let's say this is option 1. The way that Javen thought was certainly legitimate. That's good. However, there's an even simpler reason for having option 2 rather than option 1, because option 1 simply will not compile. Why?
It's in the child class.
Yeah, exactly. So let's think about how you would implement, for example, for this one here. If you say void, let's say in this class here, void set discount rate, and then here you say double, let's say discount rate. So somehow you have to assign the attributes. Let's say this dot discount rate is assigned to discount rate. Now the problem is, if you try to define this method here in the student class, it simply will not compile. We'll try that in a moment, because discount rate attribute only exists in the non-resident student class. So if you define it here, of course it wouldn't compile. That's why. Okay, let's give it a try. Okay, there's something quite subtle you have to note. Okay, let's try this. If you go back to the student class, let's say we try the following. Let's say void. Let's say set premium rates. So double premium rates. So far it's okay, just parameter. So now, however, if I say the following, this dot, you can see the premium rate is not one of the options. It is not, but let's try that anyway. Premium rate is assigned to premium rates. Okay, so now you can see that somehow this line here will not compile because premium rate is not in attributes. Okay, so we cannot do that. So we cannot define set premium rates and set discount rate methods in this class because the relevant, let me just be more complete, the relevant attributes, which are premium rates and discount rate, only exist in the child classes. That's why. Okay, just be more complete. So let me just copy this fragment of code here. We can still leave it there, but just put it in comments. First of all, copy that fragment, edit, copy, and then put it into comments. Okay, so you'll remind yourself. So now let's go to the resident students. So here you can see we do have the premium rates. We do have it. You put it there, compile just okay. So that means the set premium rate is only available for instances of type resident students. Only that. Similarly, if we go to non-resident students, so after discount rate, you can also paste the same code. But now we should say set discount rate. Set discount rate, discount, and this dot discount rate. Okay, I'll wait for you to type. Okay, once we are done with these two methods, so now let's try the tester again. Okay, so now can we just create another tester? So let's say right click on the with inheritance package, and now let's say create a new class So create a new class here, new, and then class. So let's say student tester, like that. Okay. So again, I need a main method here, like that. Okay, let's do something very similar. Okay, can we just go to the student tester in the other package? We can just copy and paste the code. If you go to the student tester, which we did before, so that's in the without inheritance package. Can we just copy everything that's inside the main method? Just that. We're going to reuse that. Okay, edit and copy. Okay, so now let's go to the new student tester, which is still empty. Okay, edit and paste. So now something, be very careful. Okay, so now here, somehow when you paste the code, they said they're going to import these three classes. You can see the course class from the without inheritance package, and the non-resident student class from the without inheritance package, etc. That's not what we need. So just delete them. Okay, just delete them, and we are fine. So somehow Eclipse does something that you don't really want, so that's why you have to delete them. Okay, so we got exactly the same code here. Let's just execute it and see what happens. The behavior should be the same. Should just be the same. Okay, you will see 625 versus 375, the same. But the internal structure of the two packages are different. So one uses inheritance, the other one does not use inheritance. The one that does not use inheritance has lots of duplicates of the code. And the one with the inheritance has the common parts that's defined in the parent class, and that's shared by each of the child classes. Okay. Any questions? No? Okay, let me illustrate another thing to actually contrast the two versions. So let's try something very simple. Okay. So now, let me, so I would suggest to avoid confusion in your Eclipse, you can just close everything. So just right click on any tab and say close all. So let's start from scratch. Okay. So now let's see what I want to do. I want to demonstrate to you if we want to make a change to, let's say, the registered course methods in version number 1 in version number 1 without inheritance, we have to make a change to multiple places. But in version number 2 with the inheritance, there's only one single place we have to change. That's something I'd like to demonstrate to you. Let's say this. So now, let's say, can we just go to the first version without the inheritance? And if you go to, let's say, resident students here, so let's say we want to change the way we want to register the course as follows. So now we want to say if, so let me just write it in English. If the number of courses is already larger than or equal to the maximum, then you should really print some error. Otherwise, you can go ahead and do it. So this is apparently just more suitable code than before. Before, we simply just check to see, we simply just do it, the else part anyway. But now we want to add the if part as well. So now, in version number 1, without inheritance, we have to add this if then else branch to resident students and non-resident students, right? Okay, let's just do the changes together. Okay, let me, so now let's go to resident students here. You can see we have the registered course over here. So let me make a comment here. So we to make a change to the, I'll just say registration policy, okay. Registration policy, this is the first place to change. So there's a second place as well. So there are 2 places. How about this is the first of the 2 places to change. Okay, that's just more obvious. Okay, so how do we change that? First of all, we have to say something like this. We would say if number of courses is already greater than or equal to the maximum number of courses, then we have to say system.out dot print line error. I'll just say error. Otherwise, we can do what we did before safely. Yeah, that's a change we're trying to make. If you want to make such a change, you have to make the change in every place where you got to register course method. Remember, since we got 2 kinds of students in version 1 without inheritance, so you're going to make the change in 2 places. Okay? So now, can we just, and this might just be what you're going to do. So if you can just copy this part here, okay, the whole thing, the comment is going to be the same. Okay, can we just copy this part here, say edit and copy. Okay, if you go to non-resident students here, in the without inheritance package, if you go there, and now, can we just replace this part here by the one we just copied? Edit and paste. Of course, you can fix the indentation here, edit, and source, and then shift to the left. Okay, good. The only thing I would like to change is, this is the second of the 2 places to change. You can see we're trying to duplicate the code, right? As you can see exactly the point. So we're going to change, let's say we've got 4 kinds of students, foreign or domestic, then we're going to copy and paste 3 times. Okay, that's really the point. So for version 1, because the common part appears multiple times, so that's why you got to change it multiple times. Now for version 2, there's only 1 single place you have to change, which is in the parent class. Only 1 place. Okay. So now let's go to version 2. So now if you go to this inheritance package here, so the only place we have to change would be the student class. Okay. So now if you want to change it, student class here, so register course here. So to make a change to the registration policy, this is the only place we have to change. This is the only place. Okay, let me just write it down. If the number of courses is larger than or equal to the maximum, then we say system.out dot print line error. Otherwise, we can do it. Okay, I'll wait for you. You can see there's only 1 place I gotta change. And somehow this updated code will be inherited to both classes. Okay, in the case you got 4 child classes of students, it will be inherited all of them. Okay, there's only 1 single place we have to change. Everybody see the point? Right? Yeah, good. It's a very important point actually about code reuse. I think there's another change I mentioned in the lecture, which is about how you calculate the tuition. You can try that as well in the lab. Okay, that's something very similar. Okay, like by applying some inflation rates to calculate the base tuition, you can just apply that over here in the get tuition method. Okay, so let's see some debugger here just to see the behavior. Okay, I would like to show you in the 2 versions. Okay. It's very important to see this in the debugger. Okay, and then we will have some time for equals method, okay, which we'll talk in more details on Wednesday, but I'd like to show some simple example first. Okay, so now can we first of all go to the tester in the without inheritance package? Okay, without inheritance, the version 1. If you click on the student tester there, okay, over here, okay, so I would like you to put a breakpoint over here, 17, right before we try to say gym.getTuition, okay, over here, right over here. So I would like to stop over there and see which version of the getTuition method that is going to be called. I would like to see that. Take a guess, which version? Remember here, in this version 1 here, we got 2 versions of the getTuition method. One that is defined in the resident students class, the other one defined in the non-resident students class. When I say gym.getTuition, which version am I going to call? Resident student, right? Because you can see line number 8. Gym is defined as a resident student. Of course, it's going to call that version there. Let's have a look to double check. And then we'll move on to the other version. So now if you say run debug as Java application. Okay, if you say that, okay, so now we are paused over here. So right before we call gym.getTuition. So now if you say step into, okay, so now we can predict we're going to go into the getTuition method in the resident students class. If you say step into, so now you can see we are in the getTuition method and we are now in the resident students class, right? That's a switch. So which means over there we're going to execute and then apply the premium rates, which makes sense. Okay, so you can just execute the code all the way, and then the tuition happens to be 625, which is right. Let's do another one. So now let's say we get to this point here. So Jeremy is a different kind of student. He is a non-resident student. Non-resident students. So now if I step into, I can predict I'm going to go into a different version of the getTuition method, which will be the version that's defined in a non-resident students class, right? If I say step into. Okay. So now if I step into it, you will see that now I'm still in the getTuition method, but now the context is different. It's not a non-resident students class, right? Very good. So now you can see in that method there, I'm going to apply the discount rate rather than the premium rates. Okay. So if you do it, and then you're going to see the tuition is 375, the discounted price. Any questions? That's for version 1. So version 2 is actually more exciting. Let's see. So let's see for version 2 where we do have the inheritance. So if you go to the student tester here, so we want to put the breakpoints around the same place. So now take a think about it. So if I say gym.getTuition, how many versions do you think we're going to run into when we run the debugger? Think about it. Remember now we do have the inheritance. So for the can it help you a little bit? So now for this one here, you really gotta understand why the debugger is going to show the behavior. But before I show that to you, remember we got students as the parent class, and we got resident students and non-resident students. We got these 2 classes. And remember we actually get the getTuition method defined over here already, which will return the base amount without any application of the premium rates or discount rates. And somehow we redefine this method here in both classes, getTuition here and also getTuition here. And of course, in the case of the resident students, we have to apply further the premium rates. And for the non-resident student here, we have to apply further the discount rate, right? So now you can see that we got 3 versions of the getTuition method. Okay? 3 versions here. Let's say 1, 2, and 3. My question to you, since I put a breakpoint in line number 17 over there, if I try to step into the getTuition, how many versions would I see for this method call here? Or maybe phrase it slightly differently. let's say I run a debugger here, and I say step into. So which version would I run into first?
One.
Okay, you think that's one?
Maybe not.
Okay, no, it's not one. Okay, so somehow the first version you will run into is 2. Because Jim is a resident student. So definitely call the resident students version first. But somehow this version here relies on this version here. Because remember we say super.getTuition over there. So now if we will see also super.getTuition in here. So we're also going to run into this eventually. So 2 and 1. So I'm going to show you the debugger. Okay. Of course, no number 3. Number 3 has nothing to do with 1 and 2. Let's see. So now since we put a breakpoint over here, so now let's say run. I'll make sure you're here. So make sure you're in the student tester inside the with inheritance package. Okay, go to that class there and maximize that. Put a breakpoint here right beside gym.getTuition. So now if you say run debug as Java application. Okay, so now let's step into it. As I said before, Jim is a resident student. So now if you say gym.getTuition, it is going to call the getTuition version in the resident student class first. Okay, let's see if that's the case. Okay, step into it. So now you can see that we are now indeed in the getTuition method here inside the resident students. You can see the first line there. It further relies on the getTuition method in the superclass, right? So now what happens if I say step into?
You go back to the student tester.
Exactly. No, not student tester, student.
Oh yeah.
Yeah. So now, just maybe repeat again. So now let's say here, you can see these are the 2 lines for implementing the getTuition method in the resident student class. So now if I say step into, I'm going to step into super.getTuition. So super here refers to the student class, right? If I say step into, so now I'll switch my context into the getTuition method in the student class. Okay, so now let's try that. If I say step into, so now indeed I'm in the getTuition method in the student class, right? So that part there is like a stage number 1. We want to calculate the base rate first. And then whatever result we get from there, we're going to apply the premium rates. Okay, so let's first of all, let's step 1 by 1. You can see that we're going to return the tuition, which is 500, which has not been applied by any rates yet. Okay, and now if you go further, so now this is where we were in the resident students class. So now we have got the result from this one here, which is 500. If you step over, you can see base now is 500. Okay, that's what we calculated from the getTuition method of the student class. So now we're going to apply the premium rates because we are in the resident students class, right? If you do that, so you can see that print line is going to print out 625. Okay, let's do a similar exercise here. So now let's say we're here, we say Jeremy.getTuition. Okay, take a guess. If I say step into, which version am I going to see? I heard 3. It's very good. Because Jeremy is a non-resident student. Very good. Yes, exactly. So let's say we step into it. So now we are now in the getTuition method in the non-resident students class, right? So now again, that one, similar to the resident students, it relies on the super.getTuition. So if you step into it, you're going to get into the getTuition method in the student class, right? So just the same code, we're just reusing it for calculating the base rate. So you do that, and then you will get a similar answer tuition, which is 500. But that one is going to be applied to a discount rate, which is 0.75, rather than the premium rates in the previous line. So if you apply that, you're going to see that you got 375, okay, rather than 625, because the rates are different. Okay, any questions about this? About how we run a debugger to see the how the inheritance works? Any questions? No? Good. Let's see how we're doing with the time. We got only 5 minutes left. Okay, I want to show you something quickly, okay, and then we're done. Okay. That'll be like a warm up for Wednesday. Can we just create another package here? So let's say new package. Let's say point equals. So let's do some simple equals method for the points. Finish. Okay, let me just close all the classes here just to avoid confusion. And now let's create a class here, new class. Let's call it points. Okay, so now for point here, we have double x, double y, and a simple constructor there. Points and double x, double y. Okay, so we say this dot x is assigned to x, this dot y is assigned to y. Okay, very simple method here. So now, let's just create a new class over here in point equals. So new class, let's call that point tester. Okay, and we have to create a main method here. Okay, let's watch the following here, okay? So now let's say this, point p1 new point. 3 and 4. Point p2 new point. Let's say 3 and 4 as well. So somehow you can see p1 and p2, they are the different addresses for different objects, but their contents are the same. And notice this is the only definition we have for the points. We have x, we have y, and we have the constructor. Okay, so now, first of all, let's see the following. If I say system.out.println, over here I say p1 equals p2 plus, so I can say here p1 equals p2. So we know that it's going to return false, first of all. Let's double check with that. Just false. No question about that. Just comparing addresses. So now, let's say this. System.out.println. If I say p1 dot equals p2, and then before I save it, okay, if I simply say p1 dot equals p2, okay, so I'll actually just save it, that's fine. So now, have you found this, would you find this strange? Because in a point class, we did not define the equals method. But now, when I say p1 dot equals p2, it compiles. Isn't that strange to you? My point is, somehow, in the point class, you can see that we did not define any equals method here. We did not. But somehow, when I say p1 dot equals p2, and p1 is an instance of point type point. When I say p1 dot equals p2, it compiles. It's kind of strange, isn't it? Right. It turns out it is not strange, because that's actually the topic I'm going to talk about. Okay, let me just explain that briefly, and then we're done. There's something you have to note. So in this case here, we say students is a superclass of RS, and student is a superclass of non-resident students. In Java, there is a class that is a superclass of every class. Okay, the class is called objects. So things are getting a little bit uglier, more ugly actually from now. So what you have to remember is somehow we have a class called objects in Java, and then everything is a subclass of the object class, including students. So the way to draw the diagram would be this. So objects is a superclass of students, and somehow student is also the subclass of RS and NRS. Okay, so now you can see somehow we got slightly more complicated arrows here. The object here is basically the parent class of students, resident students, and non-resident students. So which means whatever methods we declare in objects will be inherited to every class over here. And guess what? One of the methods in object class is equals. Okay, so over there we do have a class called equals, and we're going to take something here. Okay, I just want to write the comments here, and then we're done, and then we'll continue from here on Wednesday. Let me just write a comment here. Okay. Every class in Java is a subclass of the object class, first of all. So all methods in the object class are inherited to every class, okay, including resident students or points or whatever. Okay, this is why the following line compiles. Even though we did not explicitly define the equals method in points. Okay, just try to study this point a little bit just to see why it is the case. Okay, so the object class is something new that we didn't talk about in the lecture, but I thought it's easier to talk about in the lab while we do exercise. So object class is a class you must know, maybe after the midterm. Okay, not before the midterm, you don't have to. The object class, every method that's defined there will be inherited to every class you might define. Person, students, points, whatever. And one of the methods is called equals, which we'll talk about in details on Wednesday. Okay, that's it for today. So I'll see you on Wednesday.
Are we supposed to get a false for Q1 by false for 2?